Hello everyone, welcome to my YouTube channel. I am Harshita from Sri Venkateshwara College of Engineering. In this video, let us discuss about what is binary tree and binary tree traversal, what is graph, directed graph, undirected graph, complete graph, subgraph, path and a cycle. First, let us see the basic structure of binary tree. In a binary tree, each node has a maximum of two child left and right subtree. The top node of the binary tree is called the root node. Nodes that do not have any children are called leaf nodes. Next, let us see binary tree traversal. In order traversal, visit the left subtree and then the root and finally the right subtree. Pre-order traversal, visit the root and then the left subtree and finally the right subtree. Post-order traversal, visit the left subtree, then the right subtree and finally the root. Next, let us see example of in-order traversal. For a binary tree with nodes A, B, C, D, E, the in-order traversal would be A, B, C, D, E. In-order traversal is commonly used to retrieve data in a sorted order from a binary search tree. In-order traversal is implemented recursively. Next, let us see the example of pre-order traversal. For the same binary tree, the pre-order traversal would be D, B, A, C, E. Pre-order traversal is often used to create a copy of the tree. Pre-order traversal is also implemented recursively. Next, let us see the example of post-order traversal. For the post-order traversal, the binary search tree would be A, C, B, E, D. Post-order traversal is useful in deleting a tree from memory. Post-order traversal is implemented recursively. Next, let us see what is a graph. A graph is a non-linear data structure consisting of nodes, that is vertices and edges. Nodes are connected by edges representing relationships or connections between them. Graphs are used to model real-world relationships, networks, and independence. Next, let us see the types of graphs. Directed graph. Edges have a direction indicating one-way relation between nodes. Undirected graph. Edges do not have a direction representing a two-way relationship between nodes. Weighted graph. Edges have weights or values assigned to them. Next, let us see some of the terminology that is used in graphs. Next, let's see the node or vertex, which is a fundamental unit of graph. Edges, a connection between two vertices. Degree, the number of edges incident to a node. Next, let us see the example for directed graph. In a directed graph, edges have a specific direction. Directed graphs are used to represent relationships like social media connections or website links. Each edge has a source node and a destination node. Next, let us see undirected graph example. In an undirected graph, edges do not have a specific direction. Undirected graphs are used to represent symmetric relationships like friendships. Edges between nodes are bidimensional. Next, let us see weighted graph example. In a weighted graph, each edge has a weight or value associated with it. Directed edges are used to represent scenario where edges have specific cost or distance. Algorithms are used to find the shortest path in a weighted graphs. Next, let us see directed acyclic graph. It is shortly abbreviated as DAG. A directed acyclic graph is directed graph with no cycle. They are used in scheduling, task dependency, and topological sorting. They are meaning there is no path that start and end at the same node. Next, let us see the connectivity in graphs. Connectivity in graphs refers to how nodes are connected to each other. Strongly connected graph All nodes have a path to every other node. Weakly connected graph. There is at least one node between any pair of nodes. Next, let us see path in a graph. A path in a graph is sequence of vertices connected by edges. The length of the path is the number of the edges it contains. Paths can be used to navigate between vertex in the graph. Next, let us see cycle in graph. A cycle in graph is a path that starts and ends at the same vertex. Detecting cycles in graph is essential for various graph algorithms. Cycles can represent feedback loops or repeating patterns in a network. Next, let us see the graph representation. Adjacency matrix, a matrix where rows and columns represent vertices and entries indicate the presence of an edge. Adjacency list, a list where each vertex has a list of vertices it is connected to. These representations are used for essential graph operation and algorithm. Next, let us see graph traversal. Depth first search traverse as far as possible along each branch before backtracking. Next, breadth first search explores all the neighbors node at the present depth before moving on to the nodes at the next depth. Next, let us see DFS in a graph. DFS is nothing but depth first search is often used to detect cycles in the graph. Next, let us see BFS in graphs. Breadth first graph search is useful in finding the shortest path in unweighted graph. Next, let us see some of the applications of graphs. Graphs are used in a various applications like social networks, recommendation system, and routing algorithm. Graph theory provides a powerful framework for modeling and solving complex problems in computer. Finally, I conclude that binary trees and graphs are fundamental data structures in computer science with diverse application. Understanding binary tree traversal and the graph terminology is essential for designing efficient algorithm. Continuous exploration and applications of binary trees and graphs contribute to advancement in various fields of technology and research. Thank you for watching this video.